cruise over and not get in contact with the stone. So these are very large HFLBs. They're 3,000 tons of limestone, 1,500 apiece, and they're mainly there for manganese removal. And we have an agri-drain structure on the outlet to act as an adjustable weir to control the flow on that one, and the water level as well. But the first one, we have a drain incorporated into it. So if you want to drain it down, you can. Otherwise, the water level is controlled by the outlet channel on there. And this is just an idea of the water quality. Not currently, because I didn't have a chance to update it, but this was like a year after it was built, I believe. So, yeah, because it was built in 2010. But anyhow, it's doing a really good job. It's removing basically all of the iron, a large percentage of the manganese, basically all the aluminum, getting the pH up to 7.5, and it's really doing a good job. So some other systems that we've done, this is also a passive system. Not going to spend as much time on these. This one was in Clarion County, called the Truitsburg site. And it's a fairly small system. It basically just, a lot of these systems, whenever you build them, like the landowner's like, I don't want you to remove any trees, so you have to work in the open area, which usually, if it's an open area near the bottom of the site, it was a sediment pond and that they backfilled with a bunch of goo, and that's where the bad water is also coming out. So you have to work in a really limited space a lot of the time, which it gets challenging at times. So this one was a challenge, and the contractors that won the bid underbid it drastically because they've never built a passive treatment system before. And to kind of make that make sense to them, they stranded one operator that was about my age out there all by himself and said, build it. And they didn't really give him a whole lot of help. He didn't even have a laser level. He just had like a scope basically that he could set stuff up on his bulldozer and eyesight it and just go from there. And he was really good. And he got really frustrated sometimes too, because the bias wells that he built were straight through the sediment pond, and he sunk equipment in that thing daily. So like, and he's like, I quit. Like I'd show up to do an inspection. He's like, I quit 3 times today. He's like, just no one was here to hear me. So I got back on the machine and kept going. And I was like, well, it's looking good, you know, no problem. But basically, there is a big natural iron bog there before it started. So we had to peel all that vegetation out, put it in a pile, and they built the bias wells, and we're like, you don't need to seed it again, just sprinkle the old sphagnum back in there and everything, and it actually just continued growing. The seed bank was there, and it did a real good job. This site also has a small Jennings vertical flow pond that's in there, and then this one we actually incorporated a trompe into the outlet of the vertical flow pond, which is the first time I think it's ever been done anywhere, which is kind of interesting and fun. So the outlet comes out of the riser pipes into a box, and then it goes through a passive air compressor, basically. It's the trompe. So there's 3 legs on the trompe to accommodate low flow, like medium flow, and then high flow events. And if it gets more than that, it'll just bypass the box and go down into the aeration pool. So the bias wells are the top picture. The Jennings pond's the one on the left. In the right picture, the bias wells extend on the top of that embankment out through. And then there's an aeration pool, and then there's a wetland shelf in between 2 rock check dams with a manganese removal bed at the end. So this site basically didn't have a whole lot of iron. We were just looking to boost the alkalinity up, get aeration back into the water, and then it had a fairly high manganese concentration. Dense Run is a site up in Elk County, and it was before I started working for Biomass, but it's a really neat site, so I figured I would include it as some of the stuff that we've done. Obviously, the elk are the main attraction up in that part of the country, and I have the next slide shows exactly where the system is. But this project was done for the U.S. Army Corps of Engineers, and is a very neat system that incorporates basically the same components that are at McIntyre into this system, where they have an OPC for low pH iron removal, mixed media, vertical flow pond, and then they have settling pond wetland, and then they have some HFLBs going on there as well. So the Dense Run site is shown up through this valley in the Winslow Hill viewing area. If any of you have ever been up there, you're literally looking over the site, and you can't even tell it's there now because it's grown up so much. Which they're improving the viewing area. Like the last time we were up there, like they're increasing the parking and everything up there immensely. But the elk are perfectly happy walking through our system, feeding. Like we had to plant special plants for them to graze on because they didn't want to disturb any of that. But basically, the water starts up on the top of the pitcher, runs through that channel, which is the OTC, and into the rest of the components with the HFLP down at the far end for the manganese removal. Pine Glen, which is in Center County, was one of the active treatment systems that we've done. And these ones, they're different. You don't get as much creativity involved in the design because you're basically metering in either calcium oxide or some other chemical to treat the water. So we contacted a wastewater treatment plant that wasn't utilizing their lime silo. Ended up buying the silo off them. It was brand new. They had it on site for like a tertiary treatment thing that never got put in, and used it up there. And this site was kind of neat because there were two different sources of mine water, and they've been mining this area since like the 1930s. So some of the water was pre-act, and there was no bonds on it because they didn't have bonds then. And that was actually the larger fraction of the flow. And there was a tiny, like, 20-gallon-a-minute discharge that the people were on the hook for. And the DEP was like, well, is there a way we can build a system that we could possibly get more funding for and treat all of the water? We're like, well, yeah, we can do that. So we ended up, there's a large beaver dam above the road, which is the middle picture, and it acted like a perfect collection system, really, for all of the mine drainage in that headwaters. So it collected it all, and we're like, well, okay, well, we built a PVC Z-pile dam across that channel of the stream and put an intake there where we can say, okay, we'll take in up to, because we tried to figure out, add two flows together for a maximum, and we can treat up to, say, 300 gallons a minute of acid mine drainage. So we did that, and they phased the system, so we actually have 3 treatment ponds, and the picture on the right is looking from the top of the lime silo down the channel, and you can't really see the other 2 ponds too well, but there's 3 ponds about the same size as the one you can see spaced right down the channel. There's 2 sludge ponds up the hill, so like as you're metering in the lime, treating the water, you get a lot of the precipitates out in that first pond. Some of them will come out in the second one, and the third one's basically a polishing pond that doesn't really get much of the solids. And when they get to a point where you need to clean them out, we put in hard line sludge pump lines that the O&M contractor can just hook up to and pump all the sludge up the hill into the sludge pond. And then we have a few jobs we've been doing in West Virginia lately, and these are our most recent. Like they just finished up, probably in November. The same contractor actually built both of them. It was kind of nice because we were just dealing with one entity for both systems, which were like 10 miles apart. The first one is called the Slap Camp Trib Passive Treatment System. It was for the Friends of Deckers Creek. It was for underground mining down there. They had some portals that were discharging into a stream, almost directly into the stream in some places. So the stream was pretty well trashed above a certain point, and they had a makeshift limestone sand dosing site in the stream, and we basically covered up that footprint of that and built much more onto it to treat that water. So we built the one half of the system in the stream. So we have a large auto-flushing vertical flow pond in the top picture that discharges to the bottom right picture, which that's the settling pond with the aluminum solids in it. It shows up. It's really pretty color, and you know that it's working that way because you get the aluminum in the water coming out. It makes it turn that color blue. And then we also have another auto-flushing vertical flow pond, like directly along the road, a little bit down from that goes in, and like all of these things go into like it's about a 10-acre wetland that was all impacted. So we had to deal with the U.S. Army Corps on that to be able to impact the stream and the wetlands. So there was a fair amount of permitting that went into the North Fork Greens Run passive treatment system, really close by. It was for the Friends of the Cheat, which the Cheat is a large river in West Virginia that actually flows north and eventually to the Mon in Pennsylvania. But this system was kind of the same style of components. It had, low pH water with a lot of iron. So we actually, and the portals come out above a railroad track that you can't see. It's like to the right of the aerial picture. And so it comes down over the hill through a grouted riprap channel, and we intercepted it there and basically replaced the surface area of the rest of the channel to the stream, plus a lot more in the OPC that goes out and comes back in a hairpin shape to an auto flusher, to a settling pond with a baffle curtain, windowed baffle curtain, and then there's a mixed media Jennings overflow pond to a settling pond wetland out to the stream. And the kind of interesting thing, first with the site, was Tiff Hilton is a guy in West Virginia that was the first person who kind of noticed that iron was coming out of a low pH and wanted to utilize that technology or phenomenon, because he didn't understand why it was happening, he just knew that it was. So his name's Tiff. Sometimes we've added a new acronym, terraced iron formation, kind of to give a little bit of credit to him for what he noticed. So there's a lot of letters out there that refer to the same thing now. But the auto flusher we did here was kind of unique too, because when we were there, it's a low flow discharge the majority of the year. At times it can get flashy and get high, so we put a small siphon for the base flow, low flow situation, and then there's a larger siphon there that if that gets overwhelmed, it'll kick on too, so you can accommodate the high flows. And you can shut the low one off in high flow season if you don't want to worry about that, and then we just want to use more of your stone. A thing that I saw when we were down there doing the final inspection and stuff, there's a fernco on the overflow pipe in the siphon vault, because we were down there, I was looking around, and they already had the cover on the vault, and I was like, has it been flushing? And they're like, no, it hasn't been flushing. I was like, why not? And so I'm looking around, and their overflow pipe was just a foot too short. So all the water was just filling up, the pond was at a certain level, and it was all just going down in. So it just shows you got to look at everything, make sure everything is how it should be. And all they had to do was put a fernco and extend the riser up, and it would bring the pond level high enough to trigger the siphons. But as it was just, we call it idle, whenever the siphons don't reach the level they need to actually kick on. Some of the non-acid mine drainage type projects that we've done, we did some stream bank stabilization on both sides of Slippery Rock Creek. The side that this picture shows that's all 808 with the tree falling over was the Carney property, and they lost 50 feet of their property